Good morning students. Welcome back. We are doing chapter number 13, Chemical Effect of Electric Current. As discussed in the previous video, we have seen that liquids also conduct electricity. But the process of conduction is little bit different. Liquids conduct electricity in the form of ions, with the help of ions. How ions are formed, I have given you one introduction about that. Let us see that once again. Like suppose we have sodium chloride solution. Okay, sodium chloride is dissolved in water. So, sodium and chlorine ions are formed. As I said, ions can be positive also and negative also. So, we have one positive ion and another negative ion. Positive ions are called cations or cations and negative ions are called anions or anions. Okay. Now, how this is formed, I have already discussed with you that positive ions are formed by losing electron. When an atom loses one electron or two electrons, there is the disbalance in the number of protons and electrons. In a neutral atom, number of protons is always equal to number of electrons. That means positive and negative charges are balanced. But as electrons are lost, number of negative ions decreases. So, that atom now becomes a positive ion. Okay, like for sodium we have seen, sodium has 11 proton and 11 electron. So if one electron is lost, so this one electron, as I said, is free, it can easily be lost. So now number of proton is 11 and number of electron is 10. So this has, sodium has positive charge, sodium positive ion or cation. Similarly, for chlorine, I will just show you the structure of chlorine, how it is. Then we will move ahead with the new topic. Chlorine atomic number is 17. This we will learn next year. Why I have written this. 17 protons are there. That is positive charges. 17 electrons are there. Negative charges. So, in a neutral chlorine atom, equal number of positive and negative charges are there. But if we arrange this and see 17 proton, 17 neutron. Neutron, as I said, does not carry any charge. It's a neutral particle. Then we had arranged in the first orbit there should be only 2 electrons. In the second, it can only accommodate 8. So 1, 2, 3, 4, 5, 6, 7 and 8. How many are there now? Total 10. So now the third orbit is there. How many remaining? Total 17 we have to arrange. So 1, 2, 3, 4, 5, 6 and 7. Now every atom or every element tries to gain the stable state. Here the stable state is having 8 electrons in the third orbit for chlorine. Now there are 7. Either it can lose 7 electrons or it can gain 1. What is easy? Right? Gaining 1 electron is easy, and that 1 electron can be taken from sodium. Sodium positive and 1 electron was free. This electron can be transferred to chlorine. And now chlorine will gain 1 electron. This is an extra one. 17 proton and 17 electron were there. Now 1 more electron. So 18 electron are there. 1 extra negative charge. So chlorine is written as Cl minus or chloride ion. This is how positive and negative ions are formed. Ions can be polyatomic also. Polyatomic means having more than one atom. sodium ion. 2 sodium ions are there. And this is sulfate ion, SO4 minus 2. So this is called polyatomic ion. Okay. Now, so this is how positive and negative ions are there. And these positive and negative ions, or cations and anions, they help in conducting the electric current in the liquids. Now, what happens when electric current passes through a conducting liquid? We are talking about conducting liquids now, not about those liquids which do not conduct electricity. We are talking about either acids, bases, salts, which are good conductors of electricity. Okay, so what will happen if we pass electric current through acidified water? Pure water is not conducting electricity, so we have to add a few drops of acid in it, or we can add few drops of NaCl solution, right? Now this NaCl solution also should be prepared in water only. For that case, we can add a spoonful of salt for making the water conduct electricity. Now, what changes can be brought about by passing electric current in an electrolyte? Yes, the liquids which conduct electricity, they are given a special name, that is electrolyte. So, actually a chemical change occurs. Decomposition of this electrolyte takes place, and that process of decomposition of electrolyte by passing electric current through it is called electrolysis. And our topic for today is electrolysis, the decomposition or breaking down of the electrolyte, making new substance out of it, new maybe some gas may be released, some metal may be released, and that can be deposited on the electrode. So that process is known as electrolysis. Now this process is a very important process industrially. It is useful for various purposes. It is useful in obtaining certain chemicals, obtaining gases like chlorine, oxygen, hydrogen. It is also useful for electroplating. You must have seen artificial jewelry which looks exactly like gold and silver. That is also made by using this process of electrolysis. This is one of the applications of electrolysis. That we will discuss later on. Let us see first of all how we can carry out electrolysis. For carrying out electrolysis, we need electrolytic cell. Electrolytic cell can be easily made. We can take a beaker, fill this beaker half with any conducting liquid. Say for example, we are taking acidified water. So we are carrying out electrolysis of water. Now in this acidified water, we are putting 2 carbon electrodes, 2 carbon rods which act as electrodes. Half it should dip in water and the remaining part it should be above the water. Then this should be connected with conducting wire, copper wire it should be. Then we need a battery. You know the symbol of battery, right? And for checking whether the current is passing through or not, we'll put one LED. Okay, because weak current is there, and the another end of the wire should be connected to the second copper electrode. Carbon electrode. Okay. So this is positive end of the battery, this is negative end. So this electrode is the positive electrode and we call it anode. This is connected to the negative end of the battery. The second electrode is connected to the negative end of the battery, and so this is called negative electrode. I'm sorry, this one is the cathode and no, anode is correct here, anode, and this is cathode. Right? Now, why these names anode and cathode are given? Positive electrode is called anode, negative electrode is called cathode. That is depending on this, cation and anion. When electric current is passed through the electrolyte, this acidified water is the electrolyte. When we switch on the battery, the current passes through it, and as soon as the current passes through it, we are having positive and negative ions in the acidified water. Right? So the positive ions will be attracted towards the negative electrode. That means the cations are attracted towards the cathode. That is why this word cathode has been used. Similarly, the negative ions will be attracted towards the anode, and the negative ions are called anions. That is why the positive electrode is called the anode. Right? Now what will happen? When electric current passes through acidified water, we have evolution of two gases. In water you have which two elements? Hydrogen and oxygen. Hydrogen will form positive ions, oxygen will form negative ions. So, hydrogen gas will be released over here. So, here there will be evolution of hydrogen gas and oxygen gas will be evolved at the positive electrode. Or at the anode we will get oxygen gas and at the cathode we will get hydrogen gas. Right? So, this is electrolysis of water. Okay, we can call it, we can just change this, electrolysis of water. So in this we are getting two gases, two chemicals are found here, hydrogen and oxygen. Right? Now this process of electrolysis was first observed or shown by William Nicholson. He brought about electrolysis of water and showed that after electrolysis of water, water gets decomposed into oxygen and hydrogen gases. New substances are formed, that means it is a chemical change. So, chemical change is brought about by passing electric current. What happens? Decomposition of water, breakdown, decomposition of the electrolyte takes place. Bubbles of hydrogen and oxygen can be seen at the electrodes. On the electrodes you will find bubbles of oxygen and hydrogen gas. Right? On this electrode also. In some cases, not in this one, but if some other electrolyte is taken, there might be change in color of the solution also showing chemical effect. And in some other cases, there might be formation of layer of another metal, deposition of another metal. How this deposition of another metal takes place, we will take another example to understand that. Suppose we want to electroplate or we want a layer of copper or silver on iron. We have a simple iron spoon. I want it to look like a copper spoon or a silver spoon. So I can use this process of electrolysis. In that case, I need to change the electrolyte. So if I want to make that steel spoon look like copper spoon, I will take electrolyte copper sulfate. Copper sulfate solution will be taken as electrolyte. Okay, on one end I will take copper rod as one of the electrodes, and on the other end I will take the steel spoon or the iron spoon. Now I want that the layer should be formed on the spoon. That means I will connect this spoon to the negative end of the battery and this copper rod to the positive end of the battery. So this copper rod or copper electrode will act as anode. This will be anode, and the steel spoon will act as the cathode. And we will connect the battery, positive end this side, negative end to the spoon. Okay. Now as the electric current passes, there will be formation of copper ions and sulfate ions. Copper ions, they will move towards the spoon. They will go and deposit over here. So you will find that a brown colored layer, reddish brown colored layer will be formed on the spoon. Now there is deficiency of copper ions in the solution. So this rod, it will start dissolving. This copper rod will provide more copper ions. And a very thin layer of copper will be deposited on this spoon. And it will look like a copper spoon. This process is also known as electroplating. This is very useful in making artificial jewelry, for making things look more expensive, right? Because by coating this silver and gold, the things look more attractive and expensive. So this is one of the applications of electrolysis. We will discuss electroplating in detail in the next video, when we will learn about uses of electrolysis. Till then, have a nice day.